Hi everyone, today we're going to see what's the difference between scalar and vector product. And the scalar product is also called dot product. Let's use two vectors A and B, and the scalar product between the two is defined in two ways. The first is in angular form and the second one is by components. In angular form it is defined as the magnitude or length of A times the magnitude of B times the cosine of the angle between them. And if you have the x and y component of each vector, so let's call them a subscript x and a subscript y, you can also define the dot product as ax times bx, so the x component of b, plus ay times by. If you're in 3 dimension, you can add 8z times bz. So the result of the scalar product is always a number, not a vector, so it's a scalar. If we take a unit vector q, so that the magnitude of q is equal to 1, the dot product q dot b is the length of the projection of b along that vector, because b times the cosine of the angle theta is the projection of b along q. Also the dot product is commutative. A dot b, or in this case q dot b, equals b dot q. Because the cosine of this angle is equal to the cosine of this other angle, and the cosine is symmetric between 0 and 2 pi. The vector product, or cross product, is a little bit different, and first of all the result is in this case a vector, and if you remember we just said that the result of a scalar product is a number. So scalar product gives you a scalar, vector product gives you a vector. And what is this vector? Let's see. So the magnitude of the vector product is the length of A times the length of B times the sine of theta, unlike the scalar product which had a cosine. And try to remember the difference. We will see, I'll show you a trick towards the end of the video. And the result is a vector, but where is it going? So which vector is it? Follow closely. So the vector is, the direction of the vector is perpendicular to the plane defined by A and B. And so this is the perpendicular vector. And does it go up or down? So the direction is defined by what's called the right-hand rule. So you use your thumb on the first vector, and you have to use your right hand, it won't work with the left hand. You use the index finger on the second vector, B, and the direction is defined by your middle finger, in this case pointing up. This shows you why the vector product is not commutative, so A times B goes up, but B times A will go down. There are two other ways to tell which direction the vector product is going to go. First one, you can close your hand from A to B, and the thumb will give you the direction of the result. And so in this case, A times B is going up, and B times A will go down. You can also use the screwdriver rule, which is similar to the thumb rule. So if your screwdriver is going from A to B, your screw is going in, so this will be the direction of the result. And if you were doing B times A, your screwdriver will go in. I'd recommend the right-hand rule because it's more immediate, but if you prefer the screwdriver rule, you're more than welcome to use it. So if you have the x, y and z component of both vectors, the simplest way to calculate the result is to draw a matrix, a 3x3 matrix. And in this matrix you have the unit vectors I, j and k as the first row. In the second row you have the first vector components, and in the third row you have the second vector. And the determinant of this particular matrix is the result of the vector product. I promised I was going to show you a trick. What if you don't remember whether to use the cosine or the sine in your product? Is it the sine in the vector product? Is it the sine on the dot product? Well, I said the result of the vector product is perpendicular to the plane defined by the two vectors. But if your two vectors are parallel, well, there are infinite possible planes defined by these two vectors. So the only possible result is a vector that has a magnitude of 0. And as the angle is 0, the vector product has to have the sine in it, because the sine of 0 is 0. So this is the trick I use when I don't remember whether to use the sine or the cosine in a vector or scalar product. So there we go. I hope this helped you with your vector product doubts, and make sure you check the other topics for more engineering maths. Thanks for watching.